It's been about 20 minutes since I put my mixture on the paper and in the column, and you can see the water has traveled up the paper, it's wicked up, and it's carried that whole line of the mixture up with it, and it's starting to separate out the colors based on their solubility in the water and their attraction to the paper. You can see the blue rim on the very top, very water soluble, so it's staying with the water level. But the yellows and the oranges, not as water soluble, so they're lagging behind. Okay, this is just a good technique to separate out a mixture of chemicals with different attraction to the stationary phase, which is the paper in this case, and the mobile phase, which is the water. Okay? Now on my column chromatography, you can see something similar. I've got my mixture here, and it's been traveling down through this silica gel just from gravity, and you can see it's starting to separate out the colors also. The orange is at the very bottom in this case, and then you get some green, which is your blues and yellows, and pink up in here. The longer this goes, the more those colors will separate, because the stationary phase, the silica gel, has a certain attraction to each color, and the mobile phase, which is the water traveling down through it, has a certain attraction to each color. So based on their solubility on water again, they'll travel farther or less. Okay? And these are just both examples of how chromatography is used to take a mixture of chemicals and separate them out as they travel in a mobile phase across a stationary phase, and the different chemicals have different attractions to each phase, causing them to go faster or slower with the mobile phase and separate out. And that's called chromatography. Column chromatography, paper chromatography.